Kinematics, lots of people who do calculus relate this to physics, and that's pretty obvious because we do study it in both areas. When you're studying it in physics, you're studying it more for the visual and practical sense. The calculus behind it is more theoretical. So they do have different techniques and different answers. So in physics, you're taught to find speed by a delta distance over delta time, yes? All right, so that's the formula you're given, but that is actually an averaging of speed, of distance travelled to get speed, etc. So when we study it in calculus, we're looking for instantaneous. What is the actual thing? Actual velocity, actual acceleration at this particular time. So the difference is that when we are doing it in physics, often we don't have an equation to do it with. If we do, we substitute in and we find an average, but if we don't, we can actually measure to find out that particular thing. So we have our three letters that we use in both subjects. We have S, V, and A. A is the easy one. So what does S stand for?
Displacement.
Oh, good. Displacement. All right. V stands for, which is what? Okay. Which is where people get confused because S seems to say that it should stand for speed, but it doesn't. So those are our three things. The difference between S being displacement and S being distance is that displacement actually records direction as well. So from a point, are you moving forwards or are you moving backwards? All right? Up or down, etc. So to get between these three, we differentiate. And to get backwards, we use the process of anti-differentiation or integration, which is why they decided to put this in this standard, not in the differentiation standard. I think it's also related to the fact that there may be not so many other things practically that they can ask in the integration, whereas there's a lot on differentiation. So when we're working with this, we have different ways of writing the units. So in science, you've got meters, S with a -1, and meters, S with a -2. These are, in fact, just the same as meters per second or meters per second squared. They're just the algebraic representation of each one. So that's just something to remember if the question has this in it. It's just this. It's not. Neither of these is actually an incorrect way of writing it. Mathematically, we have started, because we're adaptable, have started to write it like physics teachers write it. So we've tended to swerve towards this particular way as well, but it may not be written like that in a question. It may be written like this. What it's saying is that we're doing a distance over a time. So for me, even in the physics formulas, this represents or visually represents the thing that they give you as formulas. So it's the change in distance over the change in time. Right? That's what delta stands for, change. That's why they use delta for the textbook, because most of it is about calculus, which is about change. So we have looked at rate of change or differentiation as a relationship. So when we differentiate, we are dealing with the rate of change of the thing that we originally had. So if we had distance or some sort of measurement of travel, then to find out the rate at which that distance is changing over time, we differentiate, all right, which gives us velocity. To find out the rate at which the speed is changing, which is called acceleration, we would differentiate. Okay, so these moves are rates of change. So that gives our link between them. So we've got two different things that we have to look out for in questions. One is, are they asking us for that physics average type of measurement, or are they asking us for an instantaneous? The instantaneous measurement is our default, so they don't have to say that. If they haven't written average in a question, they're asking you to use calculus and to substitute. So that looks like a good word. All right, so an instantaneous time means put in the time into which or whatever formula is applicable for whatever you're asking for. If you are asked about averages, let's say we pick speed, all right, then we'd be looking at the change in distance over the change, let's use this properly, in time. All right, so we'd actually be doing something like average speed over the first 5 seconds. That would be the distance for 5. Oh, I keep using D. I want it to be D. Minus the distance of 0 divided by 5 seconds. Or T of 5 minus T of 0, which would be 5. All right? So those sort of formulas, you just need to be careful of looking for the words. So the other words that you need to be careful of are the ones that relate to calculus again, but the first one is initial. There's a lot of people who don't teach this, and then their kids walk into the exam and they don't know what an initial speed is. So what is an initial speed? When we're at the start, which means that time is 0, okay? So whenever they talk about initial, they're talking about t equaling 0, all right? So we're putting in that 0. Now, there's also a lot of just general understanding that happens in these questions, things like, do you realise that if something was thrown at this point, then initial distance is probably 0, all right? Or something started here. They don't tell you that the initial distance is 0. You've got to know that if that's in the description of whatever the question is, then that initial distance is 0. So that often is helpful if you've started at something like velocity and they're saying find a formula for distance. So you've got to go back to here, and the question has told you that at t equals 0, distance equals 0, to find out that c or d or unknown that you're trying to actually put back into the formula. All right. Then we have increasing, decreasing, and constant. These can apply to either speed or acceleration, and we are talking about the rate of change. So therefore, we're talking about the derivative being greater than 0, less than 0, or equal to 0. All right? So we're talking about the first derivative of whatever it happens to be. So it would be v dashed or s dash, so v or a, being greater than 0, less than 0, or equal to 0. They could bring in the other words that we use, which are maximum and minimum speeds. treat the same as a rate of change. So differentiate, make it equal to 0, all right, solve to find out when t is. So that's the sort of procedures that they're expecting you to know all of this stuff. Most of this you've covered last year, so it will be a little bit of a step up. The step up is not usually about the actual SVA, it's about the formula you've given. So last year you were only given polynomials. Now you might be given trig functions or exponential functions or things like that and asked to solve them. Generally, if you're given exponential functions, they'll quite often have zeros in them because e to the power 0 equals 1. It makes everything nicer to solve. So you do tend to find that that's something they just tend to use. But you've got a calculator, and all you need to remember when you put it in your calculator is to make sure that you don't put it to the power of, that it's just e of whatever. All right.